Hey guys, just wanted to look at section 8.4, which is trigonometry. Just looking at some examples, a couple definitions and so on. So first of all, trigonometry involves triangle measurement, angle measure and side length when we talk about measurement. Right triangles specifically, we're pretty familiar with the right triangles. Remember that the side opposite the right angle is the hypotenuse. The other two sides are called the legs. And so in those are always opposite the two acute angles. So angle A and angle B are acute angles. And so just kind of terminology to make sure we understand. So if I'm looking at angle A right here, so like looking at that angle, BC would be the leg opposite of angle A. Segment AC would be the leg adjacent to angle A. And then AB would be the hypotenuse, is always opposite the right angle. So if I'm looking at angle B, so angle B, we're looking at AC would be the side opposite or the leg opposite angle B. Segment BC would be the adjacent leg. And then again, segment AB is the hypotenuse. So hypotenuse is always opposite the right angle. So just a couple clarifying questions here. If I'm looking at, in this particular diagram, a 3, 4, 5 right triangle, if I'm looking at angle A and I want to write a ratio, write the ratio of opposite leg over hypotenuse. Well, with respect to angle A, we have the opposite leg, which is 3. The hypotenuse is 5, so the ratio would be 3 over 5. If I'm also looking at angle A, or if I'm looking at the vertex A, and I want to do adjacent leg over hypotenuse, vertex A, so the adjacent leg would be the 4, hypotenuse is 5, so the ratio would be 4 to 5. Now if I change it and I look at the other acute angle using B, so write a ratio of opposite leg over adjacent leg. So with respect to B, opposite leg, that would be the 4, the adjacent leg would be the 3, so you're looking at a ratio of 4 to 3. And then using B, write the ratio of adjacent leg to hypotenuse. So with B, adjacent leg being the 3, the hypotenuse again is the 5. So you're looking at the ratio is 3 to 5. Now the significance of that is we have definitions that we need to talk about. Trigonometric ratios is kind of where we're going. You're looking at, if you just have a generic right triangle again, A, B, and C, C being the right angle. With respect to A, we're just talking about A. We have or opposite leg, and then this would be the adjacent leg. This is the hypotenuse. So the three definitions that we got to know is sine, cosine, and tangent. And those definitions are just based on ratios. Okay, so the sine of angle A, so I'm talking about angle A here, the ratio is opposite over hypotenuse. So if I said, what is the sine of angle A? I'm just looking for a ratio. That's this number over this number. Looking for cosine of angle A. Well, that's simply going to be the ratio of the adjacent leg over the hypotenuse. So whatever that number is over that number, and that the cosine is a ratio. And then lastly, the tangent. Tangent of angle A, it's the ratio of opposite leg over adjacent leg. So if I'm looking at this is your angle, that number over that number, that ratio would be the tangent. And the way we signify that is sine A, cosine A, tangent A. One way to remember those ratios is this acronym SOHCAHTOA. Sine is opposite leg over hypotenuse. Cosine is adjacent leg over hypotenuse. Tangent is opposite leg over adjacent leg. So that kind of helps you remember the ratios that we're talking about. All right. So looking at these examples, so this is going to be similar to what your assignment looks like. First thing we want to do is we're going to find the value of each trigonometric ratio. Now, this is simply just a ratio. We're just looking for numbers, make sure they're simplified. So as we're looking at this particular one, we're looking for sine of z. Now, I'm going to kind of refresh our memory. So, SOHCAHTOA. So sine is opposite leg over hypotenuse. So z is here. So opposite leg is 36. The hypotenuse is 39. So my answer is simply going to be taking this ratio, simplifying it. I believe that gives me 12 over 13. So my answer, the sine of z, is 36 over 39, or reduced to 12/13. Now this could be a decimal, but in our purposes here, we're going to leave it as a fraction. So looking at this particular one, now tangent of z. Tangent is opposite leg over adjacent leg. So we're looking for z is here. So this is our hypotenuse. We're not going to use that. So opposite of z is 30. Adjacent is 16. So opposite leg over adjacent leg is 30 over 16. I can reduce that. And that would give me, if I divide both of them by 2, so we're looking at 15/8. So that would be the tangent of z. Okay, just simply looking for those. And the last one, cosine. Cosine of c. Cosine is adjacent over hypotenuse. So here's c, the adjacent leg is 15. The hypotenuse is 17. It's opposite of the right angle here. And I can't reduce that, so there's my answer. All right. Now, bringing out that calculator. Okay, so we're looking for, says find the trigonometric value or ratio to the nearest 10,000. So we're actually going to use a calculator here for this. Now, to do this, just simply takes a calculator that you guys are all pretty familiar with. You have these three buttons, sine, cosine, and tangent. Make sure mine is turned on. I want to make sure I'm in degree mode. If I'm not in degree mode, I'm going to have an issue. The way you can change it is simply by hitting, making sure you're hitting this button, and we're already in degree mode. So if I want to find the tangent of 63 degrees, I'm simply going to hit tangent 63. It's already in degree mode. And I hit enter, and it says to the nearest 10,000th, which is 4 decimal places. So I'm going to go 1.9626. That's my answer. That's all I have to do. Okay, so 962 point, okay. And then let's do cosine. So let's go cosine of 47 degrees. Cosine 47. Hit enter, and that's going to give me 0.68. Well, that would be 0.19, so we're looking at 20, because I have to round to the nearest 10,000th, which is 4 decimal places. And that's all you have to do. Now, if you have a calculator like this, like Connor Dove does, okay, first thing he's going to have to do is go to mode and change it from radian to degree mode, if he hasn't already. So now we're in degree mode, and I would do the same thing. So let's go tangent 63, and I get that same answer. Okay, so just so you know. All right, now applying this. So this is where we're going to actually write some equations using those trigonometric ratios and go from there. So here we go. So it says find the missing side, round to the nearest 10th. Well, they've given me one angle, and I'm dealing with two sides. I don't know anything about the hypotenuse, but they've given me the adjacent, and they give me the adjacent leg, and I have to find the opposite leg. So this is what I have to do. Based on what I see here, I don't have anything to do with the hypotenuse. And again, I'm going to write that up here just so everybody remembers. SOHCAHTOA. Okay. So the one that doesn't deal with the hypotenuse is tangent, okay? So I'm going to write the equation, tangent of 32 degrees, because we're talking about that angle right there, equals the ratio of x, opposite, over adjacent, over 18. So tangent of 32 equals x over 18. Why did I choose tangent? Again, because the hypotenuse we don't know anything about. I'm dealing with the two legs. Now it's just algebra. So I need to get x all by itself here. So I'm going to multiply both sides by 18. So that gives me x. And this is where I'm going to bring out that calculator again. Okay. So I'm going to go 18 times tangent 32 degrees. And it says round to the nearest tenth, so I should have 11.2. So I use these approximate symbols to do that, all right, because they're not exact. I had to round. So the length of that side would be 11.2 units, okay? Do the same thing here. We are dealing with this angle, and what I see here is we have the adjacent leg and I have the hypotenuse. I don't know anything about the opposite leg, so the one that deals with opposite leg is sine, so I'm not going to use that. And it also uses tangent, so I'm not going to use that. It's got to be cosine. So I'm going to write the equation. Cosine of 29 degrees equals x over 13. Again, multiply both sides by 13, a little bit of algebra, and this is where I get to just type that in. So 13 times cosine 29, 13 times cosine 29, and that should be about 11.3. Oh, check that. I got to round 11.4. And so that's about 11.4 units. All right. So we found that one. All right. This last one's a little bit more, it's algebraically challenging. A little bit more so. But writing the equation should be pretty straightforward here. We're dealing with this angle. We have the hypotenuse involved, the adjacent involved. So adjacent and hypotenuse would be cosine. So my equation again would be cosine. So cosine of 58 degrees equals 17 over x. All right, so my variable's on the bottom here. So I'm going to multiply both sides by x. So that gives me x times cosine 58 equals 17. I got to get x all by itself, so I'm going to divide both sides by cosine 58. And that gives me x is 17 over cosine 58. Okay, so type that in. So 17 divided by cosine 58, and I have to round that to the nearest tenth, so 32.1. Okay. All right. So now what we're looking at is how do we find the measures of angles, right? So we have to find angles. And the way we do that is introduce the concept of sine inverse, cosine inverse, tangent inverse, okay? And what that does is those undo sine, cosine, and tangent, okay? So for example, if I want to get rid of tangent, so I have b all by itself here, what I'll do is I'll take the tan inverse of both sides. Those cancel each other out. I'm left with b is about this. So all I have to do now is type in. So tan inverse is second function tan. So second function tan. So tan inverse, type in that decimal, 0.0175. And then enter that in, and it's about to the nearest degree. So I'm looking at 1 degree. Okay. So if I type in this one, so this one, what I would do is go sine inverse on both sides. So I'm going to basically do this. All right, so second sine, 0.2924. And that gives me, so z is 17 degrees. So I rounded that to the nearest degree. Okay. So that's how you find the angles. Now, applying that. So again, we're going to write equations based on what we see here. We do not know the measure of this angle. So we have to decide what ratio we're going to use. And with respect to that angle, we have the adjacent leg, we have the hypotenuse. Adjacent hypotenuse would be cosine. So I'm going to go cosine of x, we'll call this x, equals 29 over 44. Now again, we've been looking at decimal, like 4 decimal places and so on, but the process is no different. So I need to get x all by itself. So I'm going to do cosine inverse of both sides. And that gives me x is about, so I'm going to type that in. So clear that out. Cosine 29 divided by 44. And that gives me, and I'm rounding to the nearest degree, so that would give me 49 degrees. All right, so do the same thing here. With respect to this is my x. I don't have anything to do with the hypotenuse, so this is opposite leg, adjacent leg, so that's tangent. So we're looking at tangent of x equals 16 over 37. So I have that equation written. Now I'm going to do tan inverse of both sides. So x is about, just going to type that in. So clear that out. Tangent, whoops, second tangent, 16 divided by 37. And I get 23 degrees. Okay. And so that's the process of using trigonometry to find missing angles.